Describing distributions. Students will be able to use the graphical display of a given dataset to describe its distribution. So in the previous unit, we looked at how to design a survey well or an experiment. But when we collect our data, it can help us to represent it visually so that we can actually understand what the trends are, what the patterns are, and to draw some conclusions about the sample and the population we want to study. We can represent quantitative data, so that's data that we measure, with either dot plots, histograms, stem plots, or box plots. Now, we're not going to look at box plots in this lesson. Box plots, I think, deserve a whole video to themselves, but we are going to look at dot plots, histograms, and stem plots, and make sure that you know how to interpret them. Let's take a look at this problem from your textbook on page 43. It says, we asked the students in a large first-year college class how many minutes they spent studying on a typical weeknight. Here are the responses of random samples of 30 women and 30 men from the class. So, as you can see, we have a bunch of numbers here. Each number represents the response of each individual in the sample. So, some man studies 90 minutes per night, 120 minutes per night, 30 minutes per night, and so on. I made some graphical displays showing the men's, and I want you to have a look at them so that we can get an idea of what these three graphical displays, dot plots, histograms, and stem plots look like. Here's our first graphical display, and it's probably the easiest to get your mind around. It's called a dot plot. You start off by essentially creating a number line. Your number line could be 1, 2, 3, 4, 5, 6 if it makes sense for your data. But in this case, I chose to make my number line in intervals of 10. Why? I had to go all the way from 0 to 300. 0 was my minimum, while 300 was the maximum amount of minutes spent studying by these guys. And so to encompass all of that, going by 10 would be easiest. Now, once I have my number line, I go through my data and I put a point or a dot over each value that I see occurring. So I can tell from this that exactly 4 individuals in the sample studies 30 minutes per night, or 6 individuals from the sample study 120 minutes per night. Now, dot plots are great if you want to see individual data. I can see exactly what my responses are. But sometimes you just want to see overall patterns and trends, and that will bring us to a histogram. You must know how to create a histogram by hand and by a calculator. So let's look at this. This histogram shows that I've created intervals of 50. These are called bins. So each interval has to be of equal width, and as you can see, on this vertical axis, I have my frequency. So how many students exactly spent somewhere between 0 and 50 minutes studying each night? Now, I can't see exactly what these 6 students, how much time they spent studying, but it can still give me an overall pattern of what's going on. We're going to return to this histogram in a moment. The final graphical display I want you to look at is a stem plot. So a stem plot gives actual, I want to make sure you can see the whole thing, actual values from our data set. The stem plot is probably one of the more complicated ones to wrap your mind around. So remember from my data set that I had up to 3-digit numbers. So I started off with labeling the first 2 digits of each of my categories. So I start from 00, 01, 02, all the way up to 30. Now when I have a line dividing my stem plot, and then on the other side, each of these values represent actual individuals. So for example here, this 30, and then the slash, and then 0 represents someone studying 300 minutes. Over here, this shows me that I have 2 individuals who studied 240 minutes. Let's look at the 04. So 0, 4, I'm thinking, okay, for 0, I get 40. I have 3 people who studied 40 minutes and 1 person who studied 45 minutes. That's the essential makeup of a stem plot. You always have to have a key to indicate what your stem plot means. So 04-5 indicates that a male student studies 45 minutes nightly. The great thing about a stem plot is that if I actually turn it this way, it's essentially a dot plot, and it takes the same shape and form of the dot plot that I created earlier. This is going to help us as we want to start to discuss some of the features of our graphical displays. So now that we've looked at 3 different types of graphical displays, we always have to interpret our graphical displays. Now we're only starting with these 3, but when we get to box plots, when we get to linear data, you still have to describe essential features of your graphical displays. So we have a little acronym to help you remember what you need to do, and it's called CUS and BS. C stands for center, U for any unusual features, S stands for spread, the second S stands for shape, and the BS stands for be specific. Be specific means always describe your center, spread, shape, and unusual features in the context of the question that you were asked. Don't make it abstract, but make it real world and tied to what you are actually being asked to talk about. So let's use the histogram that we created to analyze or to kind of interpret the graph and the data. So center is the halfway point of our data set. So if I had 30 values in this data set, because that's how many I have here, then we'd expect that halfway would be the person who has the 15th value. So if we look at this data set, this first bar has 6, this has 7. So we know the 15th is going to fall somewhere in the 100 to 150 range. So I'm going to estimate from my histogram that my center is approximately 100. Now, this may not be completely accurate based on the true data, but based on the general pattern, I can make an assumption that my center is somewhere between 100 and 150. Now, spread. Let's use spread, the most basic spread that we know, which is range. My maximum value subtracting my minimum. And so in this data set, we remember that our maximum value was 300, although based on our histogram, it looks like it could be up to 350. But we know it's 300, subtract our minimum value, which is 0. So we have a spread of 300 minutes. And our shape. So we're going to get more into shape in class, but this shape, we can say it's kind of piled towards the left with a little bit of a tail towards the right. So this shape is something that we called right skewed. Right skewed. The majority of our data is towards the left with a few data points trailing off towards the right. And then unusual features would be if we expected that there were any outliers or gaps in our data. So we do see a gap here between 250 and 300. And we also expect that this person seems to be a little bit odd out here. So we could say that this final data point at 300 could be an outlier. Now, I've given you our basic center, spread, shape, and unusual features, but remember we actually have to BS, which means we have to be specific. So what I'm going to do is take us back a second and talk about how we can put this in the context of the problem that we just were given. So based on these notes that we took up here, let's see what I wrote. I said, the center of this data is approximately 100 minutes of studying nightly. Our range is from 0 minutes of studying to 300 minutes. The shape of the data set is right skewed with a possible outlier in the 300 to 350 minute range. So now what I've done is I've taken our center, spread, shape, unusual features, and I've put it in the context of the actual information given in the problem, which was about how much do men study in minutes nightly. To summarize, we looked at 3 different graphical displays for representing data: dot plots, histograms, and stem plots. No matter what you do, when asked to describe the distribution of the data set, you must talk about center, unusual features, spread, and shape. But don't talk about them as if these numbers exist in a vacuum. Remember, you have to be specific and relate these numbers back to the context of the question you were given.